What if you used a giant magnifying glass to cook dinner? It seems like a genius idea for sustainable living. Harnessing the sun's fury with a massive lens to cook a perfect evening meal. We're thinking small, just 1 kilowatt, kW, of power, the output of a standard microwave. To capture this much sun, your lens only needs to be around 1.13 meters wide. You set up your steak, align the lens, and prepare for the world's most eco-friendly sizzle. But the laws of physics, like a stern head chef, have immediate complaints that go beyond simple overcooking. The unforeseen optical disaster, plasma air. Before the pan even registers a temperature change, we hit our first, unanticipated obstacle, akin to the Niagara Falls cavitation effect, dielectric breakdown. The air in the focus path, full of dust and moisture, acts as an insulator. But when you concentrate 1 kilowatt of sunlight onto a focal point the size of a coin, the electric field strength becomes immense. This extreme energy density instantly ionizes the air, stripping electrons from the nitrogen and oxygen molecules. The air itself ceases to be air. It becomes plasma. Your perfect sear begins with an instantaneous, brilliant white-blue flash and a thunderous crack. The air explodes into a miniature arc welding event right above your food. This is not gentle radiant heat. This is a superheated, localized solar flare that violently scatters all the contaminants in a catastrophic pressure wave. Your meal hasn't been cooked. It's been nuked by a pocket-sized ball lightning. The quantified catastrophe, a megaton dinner. But let's assume you've built your kitchen in a perfect, high-vacuum environment. Now let's stop aiming for a measly 1 kilowatt and go all out. What if you focused the sunlight from a 100-meter diameter lens? The power captured is a stunning 7.85 megawatts, MW. To grasp this magnitude, let's look at the energy flux density, the power hitting the food. If we focus this 7.85 megawatts beam down to a 1 square centimeter area, the temperature instantly rockets, far exceeding that of a welding torch or an atomic blast. This small focal point is now operating at the thermal equivalent of a low-yield nuclear fission device. Your steak doesn't turn into plasma. Its atoms are rapidly sublimated and blasted outwards at relativistic speeds, approaching 20% of the speed of light, a quantified kinetic absurdity. The sheer kinetic energy of the vaporized matter ejected from the focal point is enough to produce a shockwave equivalent to setting off 5 tons of TNT. The final planetary analogy. The ultimate absurdity lies in the power comparison. A simple residential solar panel produces about 0.4 kilowatts. The power you've focused, 7.85 megawatts, is over 19,000 times that. When focused down to that tiny spot, the heat flux density is greater than the energy output per square meter of a star's core. You didn't manage to cook dinner. You briefly created a microsingularity of stellar thermodynamics on Earth. The lesson? The giant magnifying glass is less of a kitchen gadget and more of a weapon of solar mass destruction. The 7.85 megawatts lens is guaranteed to provide one memorable meal, but it will certainly be the last supper for everyone within a quarter mile.